Hello, I'm Dave Lubach, the Executive Editor for the Facilities Market of Trade Press Media Group. And thank you for joining us for today's webcast, From Sunlight to Spotlight, Avoiding Fire Hazards in Your Rooftop Solar Installations. Our presenters today are Chris Chappell and Ankel Sangvi. Chris is the Senior Director, Engineering Services for CEA. He's equipped with 35 years of extensive experience in the power generation industry and has installed more than 2 GWs of utility scale PV solar projects and over 250 megawatts of energy storage systems throughout the United States. Ankel is an engineering manager with CEA, and he has more than 6 years of experience in the PV solar industry. He provides experience in PV cell technology and has a broad scientific understanding of solar cell technology and its manufacturing processes. Today's webcast learning objectives include: 1, understanding the most common risks found on solar rooftops, why they happen, and their resulting safety implications. 2, we'll explore case studies and real-life examples based on CEA's experience inspecting rooftops of some of the largest retailers in the US. And finally, we'll learn about best practices to rectify safety hazards found on solar rooftops. But before we get started with today's webcast, I'd like to cover a few details about today's event. We do encourage audience questions throughout the webcast, so to submit questions, please navigate to the Q&A button at the bottom of the screen and type in your questions. Our presenters will answer as many questions as time permits at the end of their presentation. All participants will receive an email within 24 hours with additional handouts from our sponsor. You will also receive a link to a brief online assessment. Upon successful completion of this assessment, you will also receive a CEU certificate. Today's webcast will also be archived at facilitiesnet.com/webcasts. And with that, I'll turn it over to Chris.
Thank you, Dave. Appreciate it. Good morning and good afternoon, everybody, depending upon where you are. Today, we're going to talk about mitigating, operational risks in your PV systems. Again, I'm Chris Chappell. I'm Senior Director of Engineering Services at CEA. I've spent most of my career as an EPC building power projects, power plants. So in that time, I've installed, roughly 2 gigawatts of solar, utility scale and rooftop solar. And what scared me most were those phone calls I'd get from either my boss or someone at the site, and saying that there was a performance issue on something that just failed. So, question I want to ask everybody, and this is a question that we ask a lot of our team members: what do you do when you get that call that says something on your roof failed? It failed in service and the system's down and we're losing production. That's one question. That's one call you're going to get. Or even worse, what if that failure caused a safety risk or put people at risk, or the building, caught fire? These are two issues we want to talk about. Go ahead, Ankel. Sorry. So what I just described were two operational risks you guys deal with every day. There's a performance risk, and a performance risk is anything that inhibits the production or the output of your solar installation, right? So that's a performance risk. A safety risk is, as it says here, a danger to persons, property, or the environment. So the picture there on the right is the safety risk. So let's talk about the performance risk a little bit. You get that call, there's an issue on your site or on your rooftop. And what we're looking at is when we design these systems, we design them with a degradation curve. The curve you see on the bottom there, the graph there, the green line at the 100% is saying on day 1, year 1, we're going to produce from here. And over time, over 20, 30 years, the system will degrade. As it degrades, we build the site and bank on that degradation. But as we get that call from site saying, hey, an inverter's down, hey, all the inverters down, I've got issues, the system isn't producing, that degradation that is greater than the planned degradation is lost money. So you're losing revenue. So you're going to get phone calls on that. The issue is we want to handle those performance issues right away so that degradation curve doesn't get any bigger. But what can happen is a performance issue that isn't handled in an adequate amount of time can turn into a safety risk. Conversely, a performance risk that can also be a safety risk at the same time as well. So what do we do when this happens? So what do we do after an event? And like this picture, we look under the hood of the car. You've got 8 guys looking under the hood of the car to figure out, what went wrong? Why did it stop? Did my carburetor go out? Am I not getting the right fuel? That's the same thing you guys are going to do. Something happens, you get an event, you get 20 people get crammed into a conference room that fits 5, and we're like these guys doing a root cause investigation. But what I really want to talk about today, before we get deep here, is there's 2 things that are happening here and 2 things we want to do. Once this event happens, just like the guys here, we're going in and trying to figure out how can we fix this. But there's what happened? What could we have done differently? How can we keep this from happening again? So the root cause analysis part is vitally important. But the second piece we want to do is what I call steps to prevent reoccurrence, STPRs. What could we have done prescriptively before this event to minimize any event on this roof? And go ahead, Uncle, sorry. What we're all trying to minimize is this dreaded thermal event on the roof. What we're trying to minimize is that event. You see it happening on the left with the fire, but that fire is actually the outcome of the effect, what happened initially. And what we see is it's the little things that can create the big issue. The big issue on this slide here is, the thermal event starts, the fire happens, and now you've got a roof that is completely decimated. On top of being decimated, the damage can go through the membrane of the roof and then into the building. And then on top of that, as they're putting fire out, they're putting water on the building, and now you've destroyed inventory. So this is a very big thing. The other thing we're trying to avoid, besides the dreaded thermal event, is the dreaded wind event. We hear a lot about the thermal events, but we really, guys, we don't want to get that call from my boss and say, hey, Chris, a module flew off the roof. It's landed in Randy's car. Luckily, he wasn't there. That's an issue. So the wind is just as detrimental as the thermal event. And the reason I say this is because here at CEA, we have done so many site safety inspections. And I'll let Uncle jump into this section of it.
Thank you, Chris. Good morning and good afternoon, everyone, to join this webinar. CEA has inspected around 600 PV systems for safety audits. These systems include carports. These systems include commercial rooftops, utility scale systems, and ground mounts. We have inspected PV systems in around 13 countries. What we have found, interestingly, is 97% of these PV systems have been found with at least one major safety concern. To put this in perspective, that is 582 sites out of approximately 600 that we have inspected. What's more interesting is most of the issues could have been avoided or could have been fixed before the thermal event. I personally have been involved as a PV expert for 13 fire investigations. And what we have realized that a lot of these issues are common sense issues that could have been avoided with proper training or proper communication.
I want to go, can you go back, Uncle? On this, when we look at this slide, I mean, I'm an EPC. This really concerns me. This means that 582 out of these 600 sites had a a single or multiple major safety issues. As a builder, as somebody who has put in 2 gigawatts, this is a frightening thing. One, for your buildings, 2, for the industry, because this is not, we've got to get that 97% down a lot less than that. It's got, I was amazed at this. So if you're seeing this number right now, these events are happening on your roofs right now. So these things are, you're not, more than likely you're part of that 97%. Anyway, sorry, go ahead, Uncle.
Thank you. What we have realized is the system owner hires an EPC to build the system. The EPC hires a subcontractor. The subcontractor hires another subcontractor, and that subcontractor hires another subcontractor. Unfortunately, people who are actually working at the site do not have any long-term incentive or do not have any long-term benefits to make the sites safe. What we have seen typically on the sites are there is a lack of communication between the site manager or the site owner and the people who are actually working at the site. A lot of times they are not aware on the training that have been imparted to the technicians who are working on the site. And this can actually lead to safety risks and issues. Most of the times, a lot of times, I would say, we are called after the thermal events happen. But I would like to reiterate that calling us before the thermal event can avoid the thermal event.
I think another issue here is, is the quality as you get down that hierarchy, like Uncle said, sub to sub to sub. What you've, I'm not sure, a lot of you may have inherited the systems on your building. A lot of you may be building the systems on your facilities. But of those that have inherited systems, you may be in a situation where the sub of the sub of the sub actually did the installation. And that's what we really want to talk about today.
Yeah, I would like to do a detailed, I would like to do a deep dive into the issues, the common issues that we find on the sites. We have found some issues like grounding issues, damaged modules, issues regarding the connectors, broken connectors, cross-mated connectors, connectors not assembled properly, cables on sharp edges, hotspots on modules, and issues inside the enclosures like water ingress and splices that are not up to. I do have some pictures.
Yeah. And as this list shows, if you look at this, these are the 10 biggest items that we found. But if you really look at these are not equipment related per se. These all have to do with workmanship of modules, inverter, and racking. We all want to look at the big things. It's the little things of the integrated system, because the modules, inverter, and racking are all integrated with wires and components. But these are the biggest issues that we see on sites.
Yeah, let's take a look at some pictures on interesting issues. In front of your screen, you see some pictures of the damaged modules. When I say module, it refers to solar panel in the layman's language. I'll use the word PV modules. The picture on the top right that you see is the PV module backsheet. When you flip the PV module, the material on the rear of the module is called as a backsheet. The pictures that we see on the top right have the torn backsheet, cracked backsheet. There may be some other damage to the backsheet. And what happens when there is a damage to the backsheet? You actually pave the way for the water or the moisture to get inside the PV modules and get in contact with solar cells. And a lot of times, it can lead to thermal events, just like the picture that you see on the left. And this can be avoided before commissioning the site by a safety inspection. And this is a completely avoidable issue. And this can happen due to a variety of reasons. This can happen because of the technicians, the way they carry the module. This can happen due to the shipping damage, or there may be variety of other reasons that can damage the module.
And it's interesting to know that back sheet scratch, you can't see it without inspection. You get up on your roof, that roof looks great. You can see the tops of your modules, it's clean. The devil is in the details underneath. So that picture on the left where that fire damage is on the top, that's from back sheet scratches. That was mishandling, and that could have been avoided by pulling those modules with the scratches, replacing them. And you wouldn't have had the downtime and the damage. I don't know, this project, that damage right there was, you know, a good $40,000, $50,000 worth of fixing of that. So those are the things we want you to look at. The picture on the bottom left is just, you know, as you're walking your sites, you want to know that's an arc flash from a cell that's misaligned and arcing with the frame. These are things as you walk, you want to look, and these anomalies can be picked up and corrected right away. Again, the STPR, what could we have done before? Assess our site. So let's keep going. This is great.
Yeah, these are some very interesting pictures. My team was at the site during the module delivery. This picture on the left is from a few years back. Modules were getting delivered while my team was on the site, and we can see the stacks of the module actually tilted. Think about the damage that modules may have gone through with every bump on the road this truck is driving. And the picture on the right it's very interesting. My team was inspecting a site back in 2018. We realized during inspection that positive side of the lead or the positive side of the cable was easily able to come off. Let me step back a little bit. What you see over here, the black colored box on the right picture is called as a junction box. When you flip the model, you can see a junction box attached to the back sheet. We have positive and negative cables coming out from the junction box. So what my team actually saw was the positive side of the lead can be pulled out just by a simple force of hand. Now think about this. Multiple PV modules are connected to each other in a string, and the string goes into the inverter. We have around 1500 volts applied, and there is a current of 10 to 11 amperes flowing. And just imagine the site is operating and this module lid comes off. This is going to be the cause for a major thermal event. Fortunately, my team was on the site and the client was super lucky to avert this major incident. And this was actually a ticking time bomb that they were not aware on the site. We were inspecting a site a couple of weeks back. This is a story from one of my recent sites. The picture on the top left, you see, the client had a crew of 10 people fixing the issues that we had found on the site. When we jumped on the roof, we realized that they were walking on the modules, they were kneeling on the modules, they were keeping their equipment on the modules. And not just that, when we go to the trade shows like RE+, we see module manufacturers marketing and advertising their modules by walking on them and showing it to you. Look how strong is our module. And what they don't realize that every time they walk on the module, they break the cells. Solar cells are very thin and they are very brittle. The picture on the right, it's similar to an X-ray. The X-ray of the human body. We call it as electroluminescence testing or EL testing. It's just like X-ray of a human body. When you have fracture or damage to a bone, you go to a doctor, you do the X-ray, and you realize and you see where you have the damage, and it's exactly similar to the X-ray of the model. This damage you do not get to see with the naked eye.
And that's really important. I mean, and what the first thing I would do here to everybody is tell the teams up on your rooftops, do not walk on the modules. Even though you just see the footprints in that middle module, which is kind of funny. Look at the EL image. This is basically where this guy's been kneeling and walking. And though you can't see any damage, as Uncle said, the X-ray or the EL image shows you all the broken bones. And the issue with the broken bones, they get bigger as time goes on. Those cracks are going to grow and grow and grow and grow. And then you have issues. So we definitely don't want to be climbing on modules. I mean, with this site, I mean, we went up there and we were just shocked. Everybody was just kind of laying on modules, and not a good thing to do. So if anything out of the webinar today, have your teams not climb on modules.
Yeah, Chris, this ties up to my point that we made in one of the previous slides, where people hire subcontractors, they are subcontractors, and they actually are not aware on who is working on their sites and what is the training they have. And this is the thing that we see quite often even today on a lot of sites that we inspect.
Yeah.
So 47 out of 100 sites that CEA has inspected were found to be having damaged modules. 31% of the sites were found to be module hotspots. Hotspot refers to a heat signature where a component is overheated more than the specifications as laid out by the manufacturer. We find out the hotspots using the infrared camera or IR camera. I think a lot of us know what an infrared camera is because we have done house inspections and a lot of other electrical inspections using infrared camera. Infrared camera catches the thermal signature of the PV component, and you get to know what is the heat signature of that component compared to other components under the same loading. So the picture on the top right, it's really interesting. You can see the checkered pattern on the module. That happens due to lightning strike, or that happens due to modules connected in cross polarities or incorrect polarities. The correct remedy to fix this issue is replacing the module, and there is no other way to fix this issue. Replace the module, get it done the right way. The picture on the bottom left, you see, we always think about, we as an owners or building managers always think about putting as many solar modules as possible on our rooftop to get maximum amount of power. But we don't know that there is geometry playing a role over here on how to design a system and how to design a racking. And a lot of times we see the racking shading the other rack behind it. When the shading occurs, this may result into a hotspot. The picture on the right, it's a thermal event, and you see there is a heat signature on the bottom of the module row due to potentially due to shading. How does this happen? This happens when technicians walk on the module. This happens due to hail damage. This happens due to shipping damage, or that there may be multiple internal defects in the modules.
You know, in the one on the bottom that Uncle was talking about, the two bottom pictures there, you see the hot spots on the right caused by the shadows on the left. Now, if this situation is, you know, it's limited to this picture, if it's consistent, this is going across the whole site. Every module is underperforming. So you've created a situation, or you've inherited a situation where the modules will be underperforming in that situation where they're shaded the whole time, and they will get worse. So this is definitely a performance issue that could grow into a safety issue.
Yeah, this is my favorite group of slides over here, where we are looking at the connector assembly issues. Let me start with few basics. All the PV modules are connected to each other using connectors. and the string of the modules then go to either combiner box or inverters. And a lot of times the connections are made using this DC connector. DC connector is a small component that is used for connecting two equipment together. And you probably have this connectors, two connectors per module. So there are thousands and thousands of connectors up on the rooftop. This is one of the most undervalued and underestimated item for a safety risk. The pic
I mean, if you look at the signature on the top, everything is cold and the connectors are hot. And like Uncle said, you have got hundreds, if not thousands of these connectors on your roof. And this to be like those little cracks that he circled there in the hole, water and electricity don't mix. Then you get ground faults, and then you get arc faults, and then you get failures, then you heat up and things happen. So I believe this is one of the biggest issues that we see right now.
Yeah, Chris, and a lot of people are still unaware that these connectors have a specific manual. They come with very specific instructions from manufacturer on how to assemble them, and they do have very specific tools to assemble them. And a lot of folks in the industry are still not aware of these issues regarding the connectors. The pictures at the bottom, you see, we have the damage or the cracked connectors. Okay, when this is the case, it paves way for water to get inside the connectors. And what happens is there is increase in the resistance between the two metal pins that are actually connecting and making the final connection. And this causes the connectors to heat up. Now, to put it in the perspective, when that over here on the picture on the top right, we are seeing that these connectors are at the temperature of 152 degrees Celsius. This is for the equipment that is rated for approximately 90 degrees Celsius, maybe even more or less. But what happens when this equipment is heated up? The plastic starts melting. The molten plastic falls on the roof membrane, and this starts a fire.
I mean, we had a client 2 weeks ago. It was a fixed tilt ground mount on a hillside. Their connectors heated up, they melted. It dropped on a dry grass. It didn't burn any of the array, but the fire went up the hill, hit a wall right before a residential, community. Didn't hit any homes, but it went like that. And it's because of connectors. What Uncle was saying is these connectors are UL listed. They're UL listed. They come as an assembly, and you can't cross mix parts. But it happens a lot, more times than not, because the threads are the same. But it's something that we look deeply at these on every site. We look at every single one. Go ahead, Uncle. Sorry.
Yeah. Cross mating is an important word. We are seeing issues regarding the connectors like improper assembly, broken connectors, cross-mated or mismatched connectors. Mismatched connectors refers to a situation where you have positive and negative side of the connector from two different manufacturers. This is a big no-no. In industry, there is a popular word called as MC for compatible, which actually it's funny, and compatibility means the plastics fit. Compatibility doesn't refer to matability and long-term usage of these connectors. These connectors, if they are mated from two different manufacturers, they are not tested, and the UL listing is not for the testing with two different manufacturers. And we have seen a lot of times connectors burning because of cross mating. The picture you see above, it's not cross mating, but it's just one of my favorite pictures where we had reported connector lying in the pool of water, and apparently no one cared to fix this. We tried hard to get them fixed, but yeah. And then 1 month later, we receive a call after when the site is operating that they saw a burnt connector on the site. And yeah, we for all the sites we inspect, we have found 40% of the sites have improperly assembled connectors, and 41% of the sites have mismatched connectors.
Yeah, it's interesting to know. When we go out, we have, there's usually someone out there from the developer or the EPC or the owner. And then when we find connectors, we say, ask them to remediate them and reinstall them. And what we end up doing is we make the request, but we watch this gentleman or gal put the connector in. And on the last site we were at, the gentleman he was all ready to go and he put them in. He did 3 of them incorrectly. And so we had to finally tell him, let's show you how to do them, because all he wanted to do was torque them down as hard as he can. And when you over torque them, you crack them. When you crack them, water gets inside. When water gets inside, everything Uncle's saying happens. So not a good thing.
Yeah, we want to stop this. We want to see this percentages coming down every day, every year. This has been one of the major issues that we are used to seeing on the sites, and cables on the sharp edges or wires on the sharp edges. This is not just regarding the PV sites, but it's rampant in all the electrical connections in the building, a lot of them. The picture on the bottom left, I was a PV expert to support the fire investigation at this site. And the pictures on the bottom left, the cables that you see are 250 kc mil cables. And we saw them on the sharp edge of the conduit. Now, if you think about it, there is a thermal cycling. The temperature changes every day, every night, and every season. This thermal cycling leads into expansion and contraction of the cables. When the cables are on the sharp edges, they rub against these edges and it damages the insulation of the cables. And this is a major issue. And we have noticed a lot of thermal events exactly due to this issue. Now, a picture on the top right, we were investigating, we were inspecting a site. And this is another example of where we averted a major issue on time. When we start the investigation, we ask the owners or the developers to turn off the system completely to make sure that we are safe during the investigation. And then we start opening the enclosures to do a deep dive, or as Chris said, looking under the hood of a car. We found that this cable on the top right was damaged while pulling the cables during construction. I would say they were just lucky. The site was operating and they did not come to know. I do not know exact story what happened before, but yeah, we found this, and this was a ticking time bomb that we defused.
Yeah, and that picture on the bottom left it was actually a really nice, the conduit, everything looked really good. But that's an explosion basically that happened right there. It destroyed all that metal, took everything apart. So again, cables on sharp edges, sub of a sub, putting the work in, you've got to look at these things, because the little tiny nick could be the next big event.
We have found this issue on 27% of our sites. To put this in perspective, that's around 27 sites out of every 100 sites we inspect. This happens due to the poor wire management by the technicians who are not qualified, lack of oversight during the construction period. And when O&M team goes on the site, what they do is they fix the issues that are already wrong. They do not inspect the sites for the safety most of the time. And they do not realize that there is something wrong on the site unless it goes wrong. And it gets into a situation where there is an emergency. All right, this is one of the other issues, poor terminations. The string of PV modules or solar panels are connected into the inverters. And these are the cables from the string of PV modules going into the inverters and terminated into a fuse block over here. If you expand the picture, if you look at both the bottom pictures very closely, you can see a copper cable, a copper strand showing out of the terminal block. On the right, the picture with the black cable that is labeled as A313N, you can see two cut strands on the cable. And when these cables are not designed to be operated when they have damaged or cut strands. This increases the resistivity and this increases the heat signature. When we do the IR picture of this cables, you can see an example picture that we have that shows there is one cable that is heated compared to rest of the cable, the one that is in yellow, that is shining. In brief, what we are trying to say is fires do not suddenly happen. We have, as owners, we have time and we have chance to look at this signs and prevent the thermal events from our side.
Yeah, so the big thing here is think of how many terminations you have on site. Think how many potential failure spots you have. So assessing that and understanding that and having that baseline is important. So again, like connectors, there's a lot of terminations.
Yep. Yeah, we have found approximately 40% of the sites having poor terminations. And by poor terminations, I mean cut strands, strands that are loose, or the cables not torqued at all, just readily coming off the termination. This is a major issue. And picture on the top left that you see is a picture after a thermal event due to a poor termination on one of the AC switchboards that we have seen over here. Yeah, and a lot of times, and not to forget that a lot of times we have seen them, we have seen technicians using the wrong tools for crimping, wrong tools for wire stripping. But even when we point out it's a poor termination, what they do is they take out the cable and they reinsert the cable and they call it good. That's not how it works. When there is a poor termination, the correct way to fix it is take out the cable, cut off the poor terminations, restrip the cable with the correct tools, and re-terminate the cable, re-torque them, and put a torque mark. The entire process needs to be repeated. So these are some of the issues I'm going to show regarding on enclosures and power electronics. Typically, a site inspection takes between 2 days to 3 days to 4 days, depending on the size of your site. If the site is small, we can complete the inspection even in a day. If you are to give me, if you as a building owner or building manager are to give me 3 hours and ask me, hey, uncle, just go to the site. You've got 3 hours and do what you have to provide me the best value you can. My choice would be to open each enclosure at your site, open inverters, open DC combiner boxes, open AC switchboards, open AC combiner panels, and inspect them. That is how I'm going to invest my 3 hours on your site. Most of the thermal events that I have participated in the investigation, not direct investigation, but supporting the investigation, the issue has originated from the enclosure. And we have inverter faults that go unnoticed. We have water getting inside the enclosures due to the bad gaskets or the conduits or the drill holes that are not fixed. We have broken or damaged components inside the inverters that are not fixed. We have incorrect fuse sizes and the breaker sizes that can lead to these thermal events.
So, I mean, what we've got here is, like Uncle said, we've done inverter investigations, rapid shutdown devices, combiner boxes, but What you see on the bottom left, there's an arc flash. It's a release of energy. You guys have power plants on your roof that have this type of energy. That release of energy actually started in the two pictures to the right, or water or other reasons, but that release, that arc flash has enough power and energy to basically, it'll take the skin right off your bones. And I've seen it happen. It's very huge. So the top pictures is a result of that. That's all mechanical pieces in there that just got completely obliterated by arc flash. So very, very important water ingress, closing your enclosures properly, but power electronics, like I said, rapid shutdown devices, we're doing a lot of thermal event investigation on them, inverters as well. So that release of energy is on your roof. We want to stay away from that. So that's why Uncle said, if you gave me 3 hours to focus on what I would focus on first, it would be here because there's more potential here.
Absolutely, Chris. I would like to highlight one of the pictures over here that shows the temperature of 160 degrees Celsius. This picture is where we found a loose screw that were not taut, and this created a high resistance path for the current to flow. And you can see this equipment is rated for 75 degrees C or 90 degrees C, and the temperature rating that we are seeing is rated for 100, and the temperature that we are seeing on this equipment is 160 degrees Celsius.
I want to, what Uncle's saying there was really important. I don't know if you caught it. A loose screw out of thousands and thousands of screws. That's the due diligence you need to do that step to prevent reoccurrence, is to get a baseline of those loose screws, because that's huge.
Yeah, and Chris, to add to that, apart from loose screws, I have seen the technicians on site stripping off the wires in right above the terminal blocks. When they strip off the wires right above the terminal blocks, there are small copper strands that go inside the terminal blocks. And we have seen a thermal event occurring from a small copper strand that went inside a terminal block. Simple things like, okay, the best practices, things like, don't strip your cables right over the terminal blocks. It's important. It's important. You may not notice the effects or the issues right when you are doing the work, but yeah, it can cause into a major fire. I love this picture. I always learned in my school days that lower temperature can increase the conductivity. Looks like this guys took it to the next level. Let me tell you, this picture is for fun. This picture is not from one of my sites, or I have not seen the actual combiner box with ice in it, similar to this. This picture was emailed to me by one of my friends few years back. And I just love this picture. This is the funniest picture. I do not have good pictures with water. It's difficult to capture in camera. So yeah, water intrusion is the highlight over here.
Well, the funny thing with this, Uncle, is you now can quantify the water because it's frozen, and the cause is basically the not adequately sealed enclosure, and it just filled up with water. I think it's phenomenally funny, but tragic.
That's true, Chris. That's true. And some of the reasons for the water intrusions are, one of the picture is on the left, where we have a loose conduit fitting. This is this loose. My bad. Let me go back to the slide.
Mm-hmm.
Yeah, the picture on the left that you are seeing is very visible. A lot of times, this loose conduit fittings are not clearly visible, and this has been a major issue for water intrusion. Yeah, a few more points to add to this. When we go to the site, we always recommend the conduits to be filled up and sealed off with appropriate and listed sealant. And the question we always get back is, show me the code, show me the NEC code. My response is, Yes, unless the conduits are coming from a different temperature area to another temperature area for which there is a code. A lot of times we recommend this as a best practice. No seal is a perfect seal, and it doesn't take a lot of time and a lot of money to seal the conduits. It's a very simple job that can be done before commissioning the site. This is the picture of the splices that we found in a pull box. This was one of the big box stores that we inspected. The picture on the right, you see the cables are connected using the splices, and the cables have a tape on them. When we went to this site, we asked the technician supporting our inspection to take off the tapes and unwrap the tapes, and we found that the cables, and they have more, we found that there were actually more splices than that were visible, and there were burnt marks on these splices. This splices are not recommended. If they have to happen, they need to undergo approval process, a proper approval process. A lot of these decisions are made on the site by a technician or an electrician. And for this specific scenario, no one knew the splices existed in this box. No one knew there was something bad going on in this box. Luckily, we found this before it can turn into a major incident. So the brief of the previous slides, we have found 26% of the sites, that is 26 out of 100 sites, were found having water ingress into the enclosures. Enclosures can be AC command panels or inverters, and the water intrusion can be due to bad gasket, damaged gasket, a screw missing over the enclosure. Yeah, we had a site that was just missing a screw over the enclosure, and poor workmanship. These are some of the examples of mechanical installation issues. I inspected this site earlier this year on the left. We had inspected this site and reported some major issues regarding the racking. There were anchor points missing. There were ballast blocks not placed as per the design recommendations from the EOR or the structural engineer. And a year and a half, we get a call that there was a wind event. Apparently, one of the module flew up from the roof, and it landed right on the zebra crossing from 1 feet from a lady that was walking, and she was very lucky that this model did not land on her.
Yeah. So another thing that happens on the ballast blocks is we've seen on the roof that the ballast blocks are taken off by people, and they're used to hold down other things on the roof. And that's definitely a no-no, because that's an engineered ballast block with weight based on wind load. So, okay, let's keep going, Uncle. We want to get some questions, but let's keep going.
Absolutely. So to summarize this one, we have found 4% of the sites having issues with mechanical installation. Now, 4% sounds very low, but let me tell you, most of the sites having issues with mechanical installation, poor workmanship, no torquing process, they are ignored during operations and maintenance, and most of these sites have some kind of issues due to the wind event. Our industry, I want to leave you all with a thought. Our industry is growing every year. We are rapidly expanding, and it's good. From 2023 to 2028, it's expected to grow from around 28 gigawatt DC capacity to around 50 gigawatt DC capacity. With rapid expansion goes down the quality. And there are many new players entering the market every day and jumping onto this business. I want to reiterate that PV systems are safe if done right.
Right. So, kind of closing out, we wanted to talk about mitigating risk, performance risks and safety risks. The issue is 97% of the sites have these risks. So what we're recommending your teams do is do that deep dive on the baseline. What can we do to prevent this from happening again? It's get an assessment of what you have. Not knowing what you have, not knowing that if you know all your terminations are good, everything's, at least you've inspected it, they're good or they're bad, and you and you can make decisions based on that. Uncle and I totally appreciate everybody's time, and I wanted to get to questions because I'm sure there's a lot of questions, but thank you all very, very, very much for attending.
All right. Well, Chris and Ankal, thank you for the presentation. And we do have some questions here from the audience. First one that I have is regarding connectors. Are there types of DC connectors that are recommended or not recommended? What would your suggestions be?
Could you please rephrase the question, Dave?
Sure. Just the type of connectors. Is there a type of DC connector that you would recommend or you wouldn't recommend?
All I would say is whatever DC connectors you use, please follow manufacturer's manual very closely. Please make sure that your team is using the right tools while assembling the connectors. And most of all, foremost, please use the connectors from the same manufacturer for male and female. A lot of times we use RSD devices that come with their own connectors. Please make sure that the connectors in the rapid shutdown devices or optimizers or microinverters are exactly same as the modules, and your team is using exactly same connectors on the DC home runs.
Okay, another question here. Asking what your experiences are with root cause analysis for manufacturing defects, examples like rapid shutdown devices and such.
We are performing root cause analysis on thermal events on inverters right now, rapid shutdown devices, racking systems. We have the capability, we have labs that can test components. So some of the components you saw there in our presentation, we do the investigation in the field, deliver it to the lab, and they do the destructive testing and the detailed root cause analysis in addition to what we found in the field. So we're doing quite a bit of those right now.
Okay. Another question here about shading. And how does shading cause hotspots?
So think about the flow of the electrons. When the module is shaded, you are actually stopping the flow of the electrons. And if the module is shaded over time, it can create a hotspot. A simple way to check is take a piece of paper, cover a solar cell for a module, and check the temperature using the IR gun with your IR camera. And you will see the cell operating at a much higher temperature than other cells.
Okay, we have one question regarding installers, and if somebody's looking for an installer, should they be looking for any certifications, or maybe what kind of aspects or what kind of things should they be looking at when they're searching for an installer?
That's a great question, because this is deep, because what you want to do is control your installers with design. Installers, you can get a big EPC and people are very qualified, but you guys all have very specific projects with very specific needs. And in there, in your notes and your design drawings, you want to tell everyone these type of connectors are acceptable, cross mating is not, and you define that. And then you meet with that EPC and you reiterate, do you understand? The other question is, are you using your own crews? Are you using your own crews? Or are you going to sub out to others? And that's what we typically find out. So what I would ask first is, are you going to sub your work out?
Another question regarding lightning. Are there any concerns about lightning strikes to rooftop PV systems?
We have seen some effects due to the lightning strikes. One of the pictures that I show that had the checkered pattern over the modules, we have seen some issues due to the lightning strike, but that rooftop didn't have the lightning conductor, or it was broken. Yeah, there have been times, but the cases are rare that we have seen the issues due to lightning strikes.
Another question asking about infrared scans and the regularity and frequency of those. How often do you recommend infrared scans?
Higher the frequency, better, but typically during normal operations and maintenance schedule, we recommend that infrared scans are done for the PV models, at least a sample of the PV modules on your site, and 100% of the enclosures every 6 months.
Another question here regarding connectors. How are some ways to inspect all of your connectors on site?
Yeah, one of the best ways to inspect the connectors without touching them is to compare the connectors and see the inconsistencies within the connectors. Yeah, there are some obvious reasons when you can say that, yeah, the connector is bad, it fails. If you see a broken connector, if you see a small crack in your connector, yeah, that connector fails. Now, there are some issues like backnut torquing. Let me go back to one of the pictures over here. Yep. Take a look at the picture on the top. The end part of the connector is called as a backnut of the connector. It has a specific torque value. Those are the issues that are difficult to identify. So what CEA does is CEA compares the connectors installed at the same time and points the inconsistencies out on the backnuts. And we ask the technicians while on the site to describe the procedure to us and do the visual inspection of the connectors and determine if they are if they use the right tools, if they did it the right way, the procedure was right or wrong, and there are at least a couple of threads being shown on the connectors. It's not completely loose, and those are some of the indications for the connectors. Yeah, and different manufacturers may have different specifications, so please take a look at the manuals.
Okay. Question about authorities to shutting systems down. So if you have do users have the authority to shut a system down if it's found to be unsafe? And if so, how can that be done safely?
We do not shut the system down ourselves unless I'm on the site and I see a fire happening right in front of me. As soon as we see a major issue on the site, and depending on what type of issue it is, we go back to the client or recommend the EPC to shut down the system. And we have a specific process. We have made a standard operating procedure to shut down the system.
We have time for a couple more questions here, so we're getting near the end of the hour. But one of our viewers was wondering about thoughts on testing utilizing thermal imaging cameras in comparison to IV curve tracing.
Yes, so that's a really good question. Usually the way I would recommend is, yeah, thermal camera points out to an issue. Sometimes you get the definite issue, but if it's a warranty issue, you can club thermal cameras with the IV curve tracing. For example, if you are 4 megawatt site on the rooftop, do 100% of the IR testing through thermal cameras, depending on what you see from your results. Select few strings or few modules, depends on what the scope of work is. Select few strings or few modules, do the IV curve tracing, and then depending upon the results on the IV curve tracing, you can do the electroluminescence testing. And yeah, CEA has clients, has helped clients on warranty enforcement using electroluminescence testing.
Question here regarding rapid shutdowns. Are rapid shutdown switches, are they a must on PV installation?
They are a must. There's NEC 930.12 makes the requirement for rapid shutdown devices. UL 3471, if you put the inverter close in towards the array, you don't need to use the rapid shutdown device. The RSD is an issue because it was put in place to protect first responders, but in essence, it's having issues with thermal events. It's on its own. So the code has created an issue for us to all deal with.
Okay. Question about training. What do you recommend beyond installer training for decreasing the amount of cables on sharp edges? And is there a way to mandate fewer sharp edges on systems?
One of the ways to do is, there are a list of trainings that I would recommend. I have 3 points in my mind. First thing is, while the site is being built, it's recommended to have the inspection done in the initial stage when they are just completed with 10 or 15% of the array. In the industry language, we call this as a golden row. So we are called onto the site when the golden row is completed, and we pick out the issues so that they do not get copied onto the other part of the system. Then the second part of the training is, there needs to be a training on with the technicians on how to route the cables. That also comes to the design part, where we already have it in the designs very detailed that, okay, this is the cable and this is how it should be routed using the specific wire clips on the site. And of course, if you are looking for the official training, it always helps to have the NAPSAP certified installers on the site.
Okay. Let's see, we'll have 2 more questions here and then we'll wrap things up. First off, would you recommend adding an infrared camera check of installation as part of specifications?
We follow NETA standards for infrared check, if that is the question.
Okay. And finally, I guess, any thoughts on technologies like optimizers that'll detect, react, and isolate many of the faults and alert O&M teams before hazards occur?
Yeah, I mean, go ahead, Uncle.
Go ahead, Chris.
I mean, so in place of, I've used optimizers a lot in places where I don't want to use a certain other components. Have issues with maybe some of the, how do I say this properly? With some of the product coming out that works efficiently, but I'd rather use the optimizer than have the issue associated with the RSD.
And I guess one last question here. We've had a great response here with questions and we thank everyone. Unfortunately, we can't get to everything, but last one was any recommendations for animal guards for animal bites on cables?
Yeah, I have a really interesting story on the animal bites. One of my clients had animal grazings on their site, and every time there was a loud sound, it was right besides the road. Anytime there was a loud sound or a loud thud or a lightning strike, the animals would start running across the PV modules, and they actually broke some of the PV modules. Yeah, what I would recommend is to have the cables in conduits as much as possible. Use the split looms to avoid to protect your cables from the animal bites. But yes, they can get through the split looms at some time, and it's necessary to audit and inspect the site.
Okay, well, that wraps up our discussion and webinar today. We thank everybody for joining. We had some great questions. Unfortunately, we couldn't get to everything, but thanks again to Chris and Uncle for joining us today. It was a great presentation and hope everybody has a great day.
Thank you, everybody. Appreciate your time.
Thank you, everyone. Thank you, Dave.